Just about 30 years ago, we didn't have any scientific proof of a planet outside our solar system. Today, thanks to advances in technology and scientific research, we've discovered over 5,300 exoplanets, alien worlds that are out there waiting to be explored. At first, these discoveries mostly involved large gas giants, but as our capabilities have expanded, we've started to uncover smaller, Earth-like exoplanets. Scientists have already found more than 50 exoplanets with masses similar to Earth and over 800 worlds with a radius less than 1/2 times that of Earth. We don't know of many such planets orbiting in the habitable zone of their parent stars, where the conditions are just right to support life. But that's already starting to change. As our search for habitable planets continues, we're beginning to discover entire planetary systems with more than one potentially habitable world. And we already know about at least one such system in our cosmic neighborhood. Logo. Our Milky Way galaxy has numerous compact systems centered around stars similar to our Sun. However, planets orbiting closely to these stars are usually too hot and, therefore, unsuitable for supporting life. But when it comes to colder, fainter stars, the habitable zone around such stars is much closer. This is Gliese 667, GJ 667, a triple star system located in the constellation of Scorpius, just about 23 light-years from Earth. It contains the first known example of a system where a low-mass star has multiple potentially habitable rocky planets orbiting within its Goldilocks zone. Similarly to Alpha Centauri, the system has 3 stars. GJ 667a is a K-type main sequence star and the largest one in the system. This orange-red dwarf has a mass of 73%, a radius of 76%, and a visual luminosity only about 12% that of the Sun. At an average distance of $12.50 is its companion, GJ 667b. It's also a K-type orange-red dwarf, about 69% the mass of the Sun, and it radiates just about 5% of our star's visual luminosity. And just like with Alpha Centauri, the most interesting is the third star. Gliese 667c is an M-type red dwarf with a mass and radius only a third of the Sun, mass 33% x-Sun, radius 34% x-Sun. It's also incredibly faint, luminosity 1.4% x-Sun, and a comparatively cold star with a surface temperature of 3,775 Kelvin, Sun surface temperature 5,772 Kelvin. Yet, despite its small size, GJ 667c has a surprisingly rich planetary system. Initially, scientists thought there were only 3 exoplanets orbiting Gliese 667c, but after revisiting existing data and making additional observations, they discovered there may actually be 6 planets in the planetary system, with 3 or even 4 of them being potentially habitable super-Earths. So what exactly is a super-Earth? The term is used to describe a planet that's larger than Earth, but not quite as large as the gas giants like Jupiter and Saturn. These planets can be made up of rock or a mixture of rock and ice, and they may have atmospheres that could support different life forms. The closest planet to the star, Gliese 667cb, is a scorching hot world at 200 degrees Celsius, 392 degrees Fahrenheit. Being the most massive one in the system, about 5.5 times the mass of Earth, this exoplanet probably has a very thick atmosphere and orbits its host star in just 7 days. The 3 potentially habitable planets in the Gliese 667 system are all located further away from their host star, and they all have masses between 1 and 5 times that of Earth, making them great candidates for habitability. Gliese 667cc, the next closest planet, orbits in the inner edge of the star's habitable zone. It has a mass of about 3.8 times and a radius 1.8 times that of Earth, with a year lasting just 28 Earth days. With an Earth similarity index of 0.85, it is known as the Holy Grail of extrasolar planets. Because of the low energy output, the habitable zone around the red dwarf GJ 667c is located very close to the star, ranging from 11 cents to 23 cents, and is entirely contained within the orbit of Mercury. To compare, Earth is located at about $1 from the Sun. Our planet would be an ice world if it orbited star C at that distance. GJ 667cc orbits its parent star 8 times closer, at approximately 12 cents, revolving around the red dwarf every 28 days. Because of this proximity, the exoplanet is likely to be tidally locked, with eternal day on one side and eternal night on the other. Drastic temperature differences between the two sides probably have a major impact on the global climate. Gliese 667cc gets about 10% less light than Earth does from the Sun. But since most of the light it receives is infrared, the planet gets about the same amount of energy as our planet does from the Sun. This would help retain water on its surface and result in a climate similar to Earth's. Since scientists don't yet know for sure if the planet has an atmosphere, or how thick it could be, it's impossible to predict its exact surface temperature. If the planet does have an Earth-like atmosphere, it would transfer heat and equalize temperatures across the entire planet, with a pleasant 30 degrees Celsius, 86 degrees Fahrenheit, on the night side. Living on such a planet would be a vastly different experience. GJ 667cc receives a faint reddish light from its star. The other two stars, Gliese 667A and B, are located at a distance of about 230 Australian dollars, much farther than the distance between Pluto and the Sun and outside the planetary system. However, they would still be visible as a pair of bright stars during the day and would shine as bright as the full moon at night. Our Sun would appear as a distant star. Unfortunately, the nearby red dwarf is known to emit flares, intense bursts of radiation, up to 1,000 times stronger than flares from our Sun. This could be problematic for any potential life on Gliese 667cc, as the planet is located so close to its flaring host star. Additionally, the strong magnetism of the red dwarf may cause star spots that can reduce the star's energy output by up to 40% for months. Combined with the lack of ultraviolet light emissions, this would be another obstacle to the formation of life as we know it. Living on Gliese 667cc would be unlike anything we're used to, not only because of the lighting conditions but also because of its stronger gravity. The planet's higher mass means its gravitational acceleration is up to 60% higher than Earth's. A person weighing 75 kilograms, 165 pounds on Earth would weigh as much as 120 kilograms, 265 pounds, on Gliese 667cc. In addition, a planet with higher mass can hold a denser atmosphere, which could result in higher atmospheric pressure at the surface. If the planet has a Venus-like atmosphere, the pressure could be hundreds of times greater, similar to the pressure found several kilometers deep in Earth's oceans.